This will be a quick demonstration on how to develop a design in Tinkercad and then how to export it, and finally how to get it ready for 3D printing using FlashPrint. So the first thing we're going to do is look at what I've created here. So this is, if I click on the cylinder, a 75 by 75 cylinder, so it's perfectly round, and it's 5 high. The units of measurement are in millimeters. And so that means that this cylinder will fit within the extruder gun that we use to extrude clay. And we can see that it's 1 millimeter because of the snap grid in the bottom here. So let's go back a few steps and put a project like this together. And you'll see it's quite simple. What I'll do is I'll just select these shapes and delete them so that we've got a completely blank workspace, as you can see there. I'm going to click on front so that we can get around to the very front of the design. So I've just been clicking on that cube there, which is our viewing cube, and I'm just going to click my right mouse and drag it down and to the side, and that will give me a nice angled view of the work plane. Now I'm going to zoom in, and I can do it using these buttons, or I can use a scroll wheel if I'm using a mouse. The first thing that we're going to do actually is give it a name. You always get these interesting names by default, but if you click on that, we can call it 3D Extruder Die Design and hit enter to save that name. So we've now got that in place. Let's build out our cylinder. We're going to click on the cylinder in the Tinkercad Basic Shapes menu. I've clicked on that, and now you can see we've got a floating cylinder and we need to place it. So you can click anywhere in that workspace. I've done that now, and it's very important to note straight away that this is a solid. It's not a hole. It's going to be the main cylinder that will form our main element. If I want, I could color it white since it will be printed white, or you can just leave it any of the default colors, but I'm going to go with white. Now it's very chunky. If we zoom in, you can see all these ridges and corners. So what I'm going to do is increase the size from 20 to 64, and that will make it as perfectly round as possible. The bevel is 0 because we don't want to curve the edge of the form. We want to keep it a nice clean cylinder, and the segments we leave as 1. If we zoom out, and if I click on it and start to grab these handles, you can see measurements. Now this needs to be no taller than 5 millimeters. At the moment it's 20.00. So if I grab this handle and pull down, I can adjust it to a height of 5. In the same way, I can grab a corner and stretch that out until it's 75 in both directions. So I might go that way and here, and you could muck around until you get it perfect, but there's an easier way. You can even click on these values and type in 75 and hit enter. And if we now zoom out, we can see that it's exactly 75 in both dimensions, therefore it's perfectly round. And if I click on the height measurement, it's 5 mils. And there we have a perfectly shaped and designed cylinder. That's the first stage of our design. Next, what we're going to do is put some holes into it, and this is what we would be pushing the clay through. So for this, I'm going to go to my top view, and I'm just going to angle it a little bit as well. There we go. To start off with, I'm going to put this great scribble shape onto it. So I'm going to grab this. It's going to float over my design, and I'm going to drop it right in the middle. It gives us a preview first if we want, because it's a scribble. So if I want, I can actually design something crazy like so and go done. So you might like that, you might not, but it's a great way to actually put some completely random stuff into your designs. I don't love that, so I'm going to hit delete, and I'm going to go back, scribble, I'm going to click, and now, I mean, if we wanted to, we could actually use the shape tool here again and do some kind of crazy stuff like that. That's not bad. Done. I'm going to zoom out, I'm going to rotate down, and I'm just going to move it more into the middle. So there we have at the moment a solid on a solid, but we know that we need this scribble shape to be a hole so that it can cut through our cylinder. That's the first step. If I go completely side on though, you can see it sits on top, and we need to make it taller so that it cuts through. So I'm going to click on that scribble shape. I'm going to make it much taller and then grab this top arrow and push it down. Can you see that it's now starting to make its way through, and it's starting to segment and create that hole? That's an underneath view, rotating through to the top view. So there we go. That's a very basic example of how you can use this great scribble tool to design custom shapes in Tinkercad. Now let's say, just to complement it, I want to put a box, so I'll click here, I'll put my box here, rotate. At the moment you can see it touches the bottom, but it doesn't cut through. So we're going to click on it, we're going to grab that arrow and push it down through the platform so that now it completely cuts through our cylinder again. Let's go from solid to a hole, and we're ready to move on. So we're going to get a design that looks like nothing I've ever seen, but that's certainly an example of how we build a die template. If I wanted to, I could also use our rotation tools and spin things around, still move them. You can also kind of skew them and stretch them just as you would any shape that you use in Tinkercad. Okay, let's now go ahead. We've got our design ready, so assume that's what we want. We're not concerned about the height, we're just concerned about the actual contours of the hole. I might just move this in a little bit more. There we go. Next stage, we hit export, and we're presented with some options. We include everything in the design, and we are exporting as an STL, which is a very universal type of 3D printing file. Hitting that, it's going to prepare the model, it's going to download it. Notice that it's given the name that we've assigned to it in Tinkercad, and we now have that file sitting in our downloads, and here it is here. The next thing that we need to do is to open software called FlashPrint. Now FlashPrint I've already installed, but you'll need to follow the links to install it yourself, or simply Google FlashPrint software and you should get to the right place. So I'm opening FlashPrint, and this is what our 3D printer work area looks like. We can go File, Load File, or we can just hit this button here. But I'll go through our File menu, File, Load File. This is going to take us into Downloads. Here's my STL file, and I hit Open. It will usually give you a warning, and in which case, just go with it. You can already see that it's getting ready to import. So I'll go Yes. You can see it's shot it straight into the middle. And again, if we use our right-click button, we can look at it from all different angles and zoom in using our scroll wheel. Those are some pretty universal controls when it comes to 3D printing. Why is the bottom blue? Because that's saying it's touching the bottom of the platform, and we want that to be the case. So, moving on. That's our view tool. We can move it around if we wanted to, but I think it's quite fine where it was, so I'll just go Edit, Undo. We can rotate it if we wanted to, but there's no need. It is important that we do a scale check though, just to make sure that the Tinkercad settings are still retained here. So I'm going to click on the scale tool, and now I'm going to click and drag. And you can see that in clicking and dragging, we've now got, as I go up and down on my mouse, the dimensions visible. So that was, at that point, 75, X, Y, it's a bit hard to read, but that says 75 as well, and Z being the height is 5 mils. So that is pretty much exactly what we need to build a scale extruder die. We're not cutting it, we're not doing anything else to it, so we can now go on to the next stage, is supports. Now this won't need a support because it doesn't have any arms or limbs or areas that protrude that may fall apart in the printing process, so we can go back. However, if you're printing something more complicated, you'd want to go with the auto supports option. Let's go back. Now we go to print, and here's where we get some really interesting and quite complicated settings to work with. The material on the left and the right should be changed, and in this instance I would direct you to our content library, and in the 3D printing section there's a page that says prepare a 3D print in FlashPrint. As you go down, these screenshots should look familiar. It's exactly what we've done already. We've done our scale check, we've done our support structure, but it's not needed. And now we're going through and we're going to match these settings. So I'll jump between both while we get these right. Material right, that's what comes out of the nozzle on the right hand side of the 3D printer. That's ABS and the left is PLA. Let's go in. So we've got material right ABS, material left PLA. Let's go back here. In the more options we're going for 27 for the layer height and first layer heights. So we'll expand more options. We'll go layer height 27, 27. That's good. Done. Now shells is 111. So again, you can see here in our screenshot, shells is 111. Fill density is 10. That's actually the density of the filament. And the more dense, the heavier it is. And also the slower it takes to print. 10% seems to be an okay fill density. So jumping back in, infill, fill density, it's 10. That's good. Speed 60 and 80. Those are defaults, so you won't have to change them. Temperature, these are again standard temps. You won't have to do anything with them. And in the others, that's a default setting that you won't be changing. I would recommend that you save the configuration so you don't have to enter this all the time, but you definitely need to be checking these each time just to make sure that things go well. A final thing you might want to do is actually create a raft. And the reason why we use a raft is it makes it easier to get your work off the 3D printed plate. Otherwise, sometimes your work can stick to the blue plate in the 3D printer. So as a final check, I would recommend a raft and just use the right extruder for that. Now that's all good to go, so we hit OK. Now it says, where do you want to save this file? You'll see that it continues to use the same naming policy, but this is an X3G file. We hit save. Very quick, you can see there that we have an example of what our printer is going to be spitting out. If we look underneath that, you can see this funny ridged disc, and that is the raft. That's the bit that we peel away and throw away after we've printed our piece. And you can see that it extends beyond the edges of the design. If we zoom in though, you'll see that we will end up with a lovely 3D printed cylinder, and that becomes our extruder die. In the top right hand corner you can see that it's going to take 36 minutes to print, and it's going to use about 4 meters of material. So that's quite a lot of material. If we wanted to, we could go back into our print settings and perhaps in the infill drop that down to 5%. We could make some other changes as well. We could also go for a lower resolution, which is probably okay considering we're simply pushing clay through a shape. So watch how this changes our settings. Low resolution faster, fill density 5%. Okay, I'll overwrite that file, save, yes, replace. Now it's a faster print and it uses a little bit less material. These dies will use a fair bit of material because we are creating a fairly solid shape. And normally 3D printing does use a fair bit of filament if we're creating work like this. Anyway, that's ready to go. A final thing is it says 17, and that means that this will be 17 layers. If we zoom right in, this will be 17 layers of the 3D print nozzle running across, and you can sit there and watch it for half an hour if you like, but I recommend that you have a book to read. Please understand though as well, you must watch a 3D print being printed. You can't walk away because you are dealing with plastic and heat, and accidents can happen. So while I'm joking about not watching your 3D print, in fact you actually do have to. We've now created our file, and it's this one here. It's the .x3g file. You then pop that onto an SD card, and let's go to our next step in our instructions. Put the SD card into the slot, as you can see here, in the front of the 3D printer, and then using these buttons and the on-screen display, you choose Print from SD and you browse to the file. When you've done that, you simply hit the Go button and wait for that time to expire. It's very important that you stay with your print, that you make sure that it doesn't overheat and there's no hazards that are caused during the printing process. And then in about 30 minutes time, you should end up with a print that looks something like this. So all the best, and I hope you enjoy creating your very first 3D print.